ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಇನ್ ಎ ಸೆಲ್ಫ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಕಾಯಿಲ್ and what's the self inductance coil value is equal to 5 millihenry. Current DI changes ಎಷ್ಟು ಚೇಂಜ್ ಆಗುತ್ತಂತೆ 2.52, so it is 2.5 to 2 ampere ಅಂದ್ರೆ 0.5 amperes change in the current in a time of dt 100th of a second. ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿದೆ. and find the EMF induced. ಇಲ್ಲೇನ್ ಮಾಡಬೇಕು 5 × 10⁻³ ಹೆನ್ರಿ ಅಂತ ರೆಡಿ ಮಾಡ್ಕೋಬೇಕು. ನೀವು ಇದೆಲ್ಲ ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು ಅಂದ್ರೆ ಯಾವಾಗಲೂ ಕೂಡ ಒಂದು ಪಿಕ್ಚರೈಸೇಷನ್ ತಂದ್ಕೋಬೇಕು. ಪಿಕ್ಚರ್ ತಂದು ಇಟ್ಕೊಂಡ್ರೆ ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳು ತುಂಬಾ ಚೆನ್ನಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ ನಿಮಗೆ, ಗೊತ್ತಾಯ್ತಾ? ನೀವು ಪ್ರಾಬ್ಲಮ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ಯಾವಾಗಲೂ ಕಣ್ಣಲ್ಲಿ ಈ ಥರದ ಪಿಕ್ಚರ್ ಇರಬೇಕು ನಿಮಗೆ. ಸೊ ಅವ್ನು ಕೇಳ್ತಾ ಇದ್ದಾನೆ ವಾಟ್ ಇಸ್ ದ EMF induced. ಸೊ ನಿಮ್ಗೆ ಗೊತ್ತಿರೋ ಫಾರ್ಮುಲಾ ಏನಪ್ಪ, ಇವರ್ E is equal to minus of L into di/dt. ಬಹಳ ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು. ಸೊ therefore your E minus 5 × 10⁻³ di is a change in the current, that's equal to 0.5 divided by 100. ಇವಾಗ ನೋಡಿ minus 5 × 0.5 is equal to ಎಷ್ಟಾಗುತ್ತೆ 2.5 10⁻³ into 100 ಎಷ್ಟಾಯ್ತಪ್ಪ minus of 2.5 × 10⁻⁻1 which is nothing but minus 0.25 volt. That's all. ಅರ್ಥ ಆಯ್ತಾ? ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರಲಿ. ಸೊ ಈ ಮೈನಸ್ ಏನಂದ್ರೆ ಏನು ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತೆ? It indicates that the direction of the induced EMF is such as to oppose the cause which is producing it. So therefore you write this value that is equal to 0.25 volt. ಅರ್ಥ ಆಯ್ತಾ ಇದು? ವೆರಿ ಗೊತ್ತಿತ್ತು, ತುಂಬಾ ತುಂಬಾ ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್ ಇದು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಯು ಸ್ಟಡಿ ದ ಪ್ರಾಬ್ಲಮ್ ನಂಬರ್ 2. ಎರಡನೇ ಪ್ರಾಬ್ಲಮ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ಓದಿ. ಕರೆಂಟ್ ಇಂದ ಕರೆಂಟ್ ಇಂದ ಪ್ರೈಮರಿ ಆಫ್ an adjacent coil changes from 3 amperes to 5 ampere in 100th of a second. So the current changes from 3 to 5 amperes in 100th of a second. Okay. ಇವಾಗ time has given. He has given the time as t is equal to 100th of a second. So ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರಬೇಕು. And if the average EMF induced is equal to 200 volt. So average EMF induced is equal to 200 volt. ಕೇಳ್ತಾ ಇರೋದೇನು? Calculate the mutual inductance. Calculate the mutual inductance. ಸೊ ಇವಾಗ ಇಲ್ಲಿ ಮ್ಯೂಚುವಲ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಬಂದಾಗ ಜ್ಞಾಪಕ ಇರಬೇಕು, ಇದು ಪ್ರೈಮರಿ ಕಾಯಿಲ್ ಅಂತ ಕರಿತೀವಿ, ಆಮೇಲೆ ಇಲ್ಲೊಂದು ಸೆಕೆಂಡರಿ ಕಾಯಿಲ್. ನೀವು ಈ ಥರ ಕಣ್ಣಲ್ಲಿ ಪಿಕ್ಚರ್ ಇದ್ರೆ ಮಾತ್ರ ನಿಮ್ಮ ಪ್ರಾಬ್ಲಮ್ಗಳು ಅರ್ಥ ಆಗೋದು. ನೀವು ಸುಮ್ಮನೆ ಕಣ್ಣು ಮುಚ್ಕೊಂಡು ಇಮ್ಯಾಜಿನೇಷನ್ ಇದ್ದಾನೆ ಮಾಡಿದ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಉತ್ಪಯಿಸೋದು ಅರ್ಥ ಆಗಲ್ಲ ನಿಮಗೆ. ಸೊ ಅಫ್ಕೋರ್ಸ್ ಯುವರ್ ಫಾರ್ಮುಲಾ ಇಸ್ E is equal to minus of m into di/dt. ಅಲ್ವಾ? ಡೈರೆಕ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. EMF induced is 200 volt minus of m into change in the current is equal to -2 divided by 100. ಏನಾಗುತ್ತೆ ಆವಾಗ? therefore your 200 is equal to minus of minus plus ಆಯ್ತು 2 into 100 again. So this 200 get cancelled and therefore your value is equal to 1 Henry. ಯೂನಿಟ್ ಜ್ಞಾಪಕ ಇರಬೇಕು, 1 Henry. Okay, 1 Henry. ಸ್ಮಾಲ್ ಲೆಟರ್ಸ್ ಅಲ್ಲಿ ಬರೆದ್ರೆ ಫುಲ್ ನೇಮ್ ಬರೀಬೇಕು ಅವಾಗ. ಅರ್ಥ ಆಯ್ತಾ? ತುಂಬಾ ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ. ಲಾಸ್ಟಿಗೆ ಒಂದು ಸೆಂಟೆನ್ಸ್ ಬರಬೇಕು. therefore mutual inductance between the pair of coil is 1 Henry. Very simple problem these are all. Okay, come to the problem number 3. The mutual inductance between the primary and the secondary coil of a transformer is 0.6 Henry. So he has given the capital M as 0.6 Henry. Next ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ? ನೆಕ್ಸ್ಟ್ ನೋಡಿ, calculate the induced EMF in the secondary coil when the primary current changes at the rate of 5 ampere per second. So the primary current changes at the rate of 5 amperes per second. ಕೇಳ್ತಾ ಇರೋದೇನು? ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ EMF induced. ಸೊ ಅವಾಗ ನಿಮ್ಗೆ ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು, EMF ಇಲ್ಲಿ ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ಕರೆಂಟ್ ಇಲ್ಲಿ ಚೇಂಜ್ ಆಗುತ್ತೆ di/dt. ಓಕೆ, ಸೊ ಅಫ್ಕೋರ್ಸ್ ಇವರ ಫಾರ್ಮುಲಾ ಇಸ್ E is equal to minus of m into di/dt. minus of m is ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 0.6 and it changes at the rate of 5 ampere per second. So ಎಷ್ಟಾಗುತ್ತೆ? This is equal to minus 3 volt. ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರಬೇಕು. Okay, so 5 amperes per second, 0.6 into 5 is equal to, so it is equal to 3 volt. So last one sentence ಬರಬೇಕು. Therefore the EMF induced is equal to ಎಷ್ಟಾಗುತ್ತೆ? 0.3 volt. Simple and elementary problem it is. Okay, now you come to the problem number 4. Come to problem number 4. The magnetic flux linked with the coil placed perpendicular to the magnetic field is given by flux phi is equal to 40 square plus 3t plus 2. The flux linked with the coil is given by the formula 40 square plus 3t plus 2. This is the flux linked with the coil. Next time where flux is in Webers and t is in second. Find the EMF induced in 0.1 second. Find the EMF induced. So he wants to calculate the EMF induced in a time of 0.1 second. Again, you differentiate this. So differentiate this with respect to time. Differentiate with respect to time. ಯಾಕಂದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಿದೆ, so with respect to time differentiate ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? Flux change ಆಗುತ್ತೆ. d5 by dt is equal to d by dt of 40 square plus 3t plus 2. So that EMF induced is given by the formula minus E, or just you can write it is equal to E. Differentiate ಮಾಡಿದ್ದ ನಿಮಗೆ ಗೊತ್ತಿದೆ, this is nothing but the 4 into 2 is equal to 8t plus this is equal to 3 plus 0. And therefore your EMF E is equal to 8t plus 3. He says in a timer when t is equal to 0.1 second. So you substitute that. Therefore your E is equal to 8 into 0.1 plus 3, and therefore EMF is equal to 0.8 plus 3, and EMF is equal to 3.8 volt. ತುಂಬಾ ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು. Okay, so ಈ ಪ್ರಾಬ್ಲಮ್ಸ್ ಗಳನ್ನ ಚೆನ್ನಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ. We'll go ahead with the other problems now. Copy down this problem. Very very simple problem this problem. ಇದು ಅಷ್ಟೇ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರೋ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕು. 4 8 3 3 ಪ್ಲಸ್ 0 and 80 plus 3 ಆಯಿತು. when time is equal to 0.1 second. He has said at a time of 0.1 second. So I can put t is equal to 0.1 here. Therefore you will get 0.8 plus 3, it is equal to 3.8. Okay. Study the question number 5. A square coil of 100 turns with side 5 centimeter is suspended with its plane at right angles to the uniform magnetic field of strength 5 into 10 to the power minus 3 Tesla. What is the charge developed in the coil? Of resistance 50 ohms, and the coil is rotated through 60 degree. Study the problem carefully. You know that here is the magnetic field, and in this magnetic field he is rotating a coil. What kind of coil he is rotating? A rectangular, this is square coil. Square coil and its length and breadth will be the same. Okay, this is the north and south pole. This is a square coil he is rotating. So ಒಂದೊಂದೇ ಡೇಟಾ ಬರಿತಾ ಹೋಗಿ, ಯಾವಾಗಲೂ ಪ್ರಾಬ್ಲಮ್ನ ಓದ್ತಾ ಡೇಟಾ ಬರಿಬೇಕು. So he has given that the number of turns is equal to 100, and he has said each side is equal to 5 centimeter. When each side is equal to 5 centimeter, your area is equal to length into length. So that is 5 centimeter into 5 centimeter, and that's equal to 5 into 5 is 25. When you convert this centimeter into the meter, it is equal to 10 to the power minus 2, 10 to the power minus 2, minus 4 meter square ಆಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ? ಆಮೇಲೆ ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ? And in a uniform magnetic field of strength 5 into 10 to the power minus 3 Tesla. He has given this capital V as 5 into 10 to the power minus 3 Tesla. Next ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ? What is the charge developed in the coil? He says, what is the charge developed in the coil? ಯಾವಾಗ? If the resistance of the coil is equal to 50 ohms ಇದ್ದಾಗ, ಮುಂದೆ and the coil is rotated through 60 degree. ಮೊದಲಿಗೆ ಹಿಂಗಿದ್ದ ಕಾಯಿಲಿಂದ 60 degree. ಅಂದ್ರೆ ಅರ್ಥ ಏನಾಗೋಯ್ತು? θ1 is 0 and θ2 is equal to 60 degree. ಫಸ್ಟ್ ಈ ಪ್ರಾಬ್ಲಮ್ನ ನೋಡಿ, ಹೇಳಿರೋದನ್ನ ಕರೆಕ್ಟಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಇದು ಒಳ್ಳೆ ಪ್ರಾಬ್ಲಮ್, 5 ಮಾರ್ಕ್ಸಿಗೆ ಬರೋ ಪ್ರಾಬ್ಲಮ್. ನಿಮ್ಗೆ ಅರ್ಥ ಆಯ್ತು. when the coil is rotated in a magnetic field, you know that the flux linked to the coil changes according to Faraday's law, and EMF is induced. And you know that from Faraday's law ಏನಂತ ಗೊತ್ತಿದೆ? your E is equal to minus of d phi by dt. d phi ಅಂದ್ರೆ change of flux, dt ಅಂದ್ರೆ change of time. I hope you know that your E is equal to V, V is equal to Ohm's law ಪ್ರಕಾರ it is IR. ಅವಾಗ ನಾನು ಏನು ಬರಿಬಹುದು ಇಲ್ಲಿ? IR is equal to minus of d phi by dt. I ಅಂದ್ರೆ ಏನು? dq by dt ಅಂದ್ರೆ rate of change of current is nothing but the rate of flow of charges into 1 by r into d phi by dt. r ನಲ್ಲಿ ತಗೊಂಬಂದೆ. I ಅಂದ್ರೆ dq by dt. ಇಲ್ಲಿ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು, because your current is nothing but the rate of flow of charges. dt get cancelled, and therefore your charge developed dq is equal to minus of 1 by r d phi by dt. d phi, that's all, d phi, and it is equation number 1. Okay. ನೆಕ್ಸ್ಟ್ ಏನಪ್ಪಾ? ನೆಕ್ಸ್ಟ್ ಏನು ಕೇಳ್ತಾ ಇದ್ದಾರೆ? ಈಗ ನಿಮ್ಗೆ ಇಲ್ಲಿ dt ಕ್ಯಾನ್ಸಲ್ ಆಗೋಯ್ತು. d phi ಚೇಂಜ್ ಆಫ್ ಫ್ಲಕ್ಸ್ ಕಂಡುಹಿಡಿಯಬೇಕು. ಚೇಂಜ್ ಆಫ್ ಫ್ಲಕ್ಸ್ ಅಂದ್ರೆ ಹೇಗೆ ಕಂಡುಹಿಡಿಯಬೇಕು? ಇವರ d phi is equal to phi 2 minus phi 1. ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರಬೇಕು. ಸೊ d phi, ಸರ್ phi 2 ಅಂದ್ರೆ ಏನು? phi ಅಂದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, ಇಟ್ಸ್ NAB cos of theta 2 minus NAB cos of theta 1. Alva, flux linked to the coil is so much, and therefore your NAB is a common factor, cos theta 2 minus cos theta 1, and therefore your NAB cos of theta 2 ಅಂದ್ರೆ 60 degree, cos of theta 1 ಅಂದ್ರೆ 0 degree. Alva, therefore your NAB cos 60 ಅಂದ್ರೆ ಎಷ್ಟು? half, cos 0 is equal to minus. Therefore ಎಷ್ಟಾಗುತ್ತೆ? minus of NAB. This is nothing but the change of flux. You substitute this value of 2 in the equation number 1. Therefore your dq is equal to minus of 1 by r into minus of half NAB. Half of cancel ಆಗುತ್ತೆ. Therefore your dq is equal to NAB by r. Now you substitute these values. Therefore your charge developed is number of turns, he has said 100, area 25 into 10 to the power minus 4, strength of the magnetic field 5 into 10 to the power minus 3, whole divided by capital R, R is equal to 50. Therefore first problem na simplify ಮಾಡಿ, first correct ಆಗಿ ನೋಡಿ ಏನೇನು ಹೊರಟೋಗ್ಬೋದು, ಏನೇನು ಮಾಡ್ಬೋದು ಅಂತ ನೋಡಿ. 25 1s are 25 2s are ಹೊರಟಾಯ್ತು. ಅರ್ಥ ಆಯ್ತಾ? ಇವಾಗ ನೋಡಿ, ಇದು 10 to the power minus 4, 10 to the power minus 3 minus 7, ಇಲ್ಲೊಂದು ಪ್ಲಸ್ 2 ಹೊರಟಾಯ್ತು. ಎಷ್ಟಾಯ್ತು? minus 5. therefore ಅವಾಗ ನೀವು ನೋಡಿ 5 1s is 5 by 2 into 10 to the power of minus 5 ಕೂಲಂಬ್ ಆಯ್ತು. ಅರ್ಥ ಆಯ್ತಾ ಹೆಂಗೆ ಅಂತ? ಸೊ ಇವಾಗ ಇದನ್ನ ಡಿವೈಡ್ ಮಾಡಿ 2.5 into 10 to the power minus 6 coulomb. That much of charge is developed. 25 into 10 to the power minus 5 minus 6 ಬೇಕಾದ್ರೆ ಏನು ಮಾಡಿ? multiply and divide by 10 ಮಾಡಿ. ಆವಾಗ your dq is equal to 25 into 10 to the power minus 6 coulomb, and therefore this is nothing but 25 microcoulomb. Okay, so what is the charge developed? 25 microcoulomb. Last one sentence ಬರೆಯೋದು ರೂಢಿ ಮಾಡ್ಕೋಬೇಕು. therefore the charge developed is equal to 25 microcoulomb. ಅರ್ಥ ಆಯ್ತಾ? ಪ್ರಾಬ್ಲಮ್ ಸಿಂಪಲ್ ಆಗಿದೆ, ಫಾಸ್ಟ್ ಆಗಿ ಯೋಚನೆ ಮಾಡಬೇಕು. ಇದನ್ನ ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಫಸ್ಟ್ ಕ್ಲೀನ್ ಆಗಿ ಡೇಟಾ ಬರೀಬೇಕು, ಆ ಪ್ರಾಬ್ಲಮ್ ನ ಓದ್ಕೊಂಡೇನೆ ಡೇಟಾ ಬರೀಬೇಕು. ಸೊ ಇಲ್ಲಿ ಬಂದಾದ್ಮೇಲೆ ಇವೆಲ್ಲ ಬೇಸಿಕ್ ಡೆಫಿನೇಷನ್ಸ್ ಗೊತ್ತಿರಬೇಕು. dt ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಫ್ಲಕ್ಸ್ ಗೊತ್ತಿಲ್ಲ, ರೇಟ್ ಆಫ್ ಚೇಂಜ್ ಆಫ್ ಫ್ಲಕ್ಸ್. ಫ್ಲಕ್ಸ್ ಅಂತಂದ್ರೆ ಏನು? 5 2 minus 5 1 ಚೇಂಜ್ ಆಫ್ ಫ್ಲಕ್ಸ್. ಸೊ NAB cos theta ಜನರಲ್ ಫಾರ್ಮುಲಾ, cos theta 2 minus cos theta 1 ಇವೆಲ್ಲ ಚೆಕ್ ಕರೆಕ್ಟ್ ಆಗಿರುತ್ತೆ. ಓನ್ಲಿ ದ ಆಂಗಲ್ 0 ಇದ್ದು ಥಿಂಗ್ 60 ಡಿಗ್ರಿ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಷ್ಟೇ. ಅರ್ಥ ಆಯ್ತಾ? ಅವಾಗ this is the value. Okay, remember this. Yes, now you study the problem number 6. A closed rectangular coil of turns 200. So number of turns in the coil is equal to 200. Then of area 0.75 meter square, its area is equal to 0.75 meter square. Having a resistance of 50 ohms, the resistance of the coil is equal to 50 ohms. Next ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ? And is placed with its plane at right angles to the uniform magnetic field of strength 4 into 10 to the power minus 5, 4 into 10 to the power minus 5 Weber per meter square is the strength of the magnetic field. This is the strength of the magnetic field. Calculate the quantity of charge passing through it. That is a dq. Same kind of charge, same kind of problem. When the coil is rotated through an angle of 90 degrees, theta 1 is equal to 0 and your theta 2 is equal to 90 degrees. It's the same kind of problem. Okay, I hope you can follow this problem. It's the same kind of problem again. So from Faraday's law, you know that your E is equal to minus half d phi by dt from Faraday's second law. And you know that your E is equal to V is equal to IR. It's the same problem. We have changed the number. We have changed the values, that's all. And therefore your IR is equal to minus half d phi by dt. And you know that your I is equal to dq by dt. And therefore your dq by dt is equal to minus half 1 by r into d phi by dt. dt get cancelled. And therefore again your formula is dq is equal to minus half 1 by r into d phi, which you can take it as equation number 1. And you know that the change of flux is given by your d phi is equal to, once again it is equal to phi 2 minus phi 1. So it is equal to NAB cos theta 2 minus NAB cos theta 1, as you remember in the previous case. And your NAB is a common factor, you take it out, cos of theta 2 minus cos of theta 1. Theta 1 ಅಂತಂದ್ರೆ ನಿಮಗೆ ಜ್ಞಾಪಕ ಇರಬೇಕು, ಕಾಯಲ್ ಹಿಂಗಿತ್ತು placed, it is placed perpendicular to the magnetic field, ಅಂದ್ರೆ starting ಇದು, it is rotated through 90 degree. Okay, so from the vertical ಅವಾಗ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ, ಇವಾಗ NAB into cos of 90 minus cos of 0, and therefore it is NAB, so cos 90 is equal to 0 minus 1, which is nothing but the minus NAB, that is the d phi. And therefore your dq is equal to minus half 1 by r into minus half NAB. And therefore it is NAB by r. Once again, same kind of problem it is. It is a dq. You are calculating equation number 2. You can do it fast. Next is the problem, that is you substitute all these things in the equation. Therefore your dq is equal to, so minus of minus plus is equal to NAB by r. Number of turns he has given it as 500. Area is given to be 0.75. Into B is the strength of the magnetic field, 4 into 10 to the power minus 5. Whole divided by capital R. Capital R is equal to 50 ohms. So now you work it out. And you know that 50 ones are 50, it is equal to 4s are. And these two, if you multiply, 0.75 into 4 is equal to 3. And therefore you are 4 into 3 into 10 to the power minus 5. That comes out to be 12 into 10 to the power minus 5 coulomb. And if you multiply and divide by 10, and it comes out to be 120 into 10 to the power minus 6 coulomb, which is nothing but 120 microcoulomb. That's the value of D. I hope you have followed this one and you should be good at calculations. Okay? Problem is, a circular coil of turns 220. Circular coil of turns 220, number of turns 220, having a radius of 0.1 meter. So 0.1 meter, and here inside is a circular coil. You need not be using always the rectangular or the square coil, and it's a circular coil, and he has given the radius of the circular coil as 0.1 meter. is placed at right angles to uniform magnetic field of strength capital B is equal to 0.05 Weber per meter square, and if you want you can just write it as 5 into 10 to the power minus 2 Tesla. Okay, Weber per meter square is also called as a Tesla. Find the EMF induced in the coil. Find the EMF induced in the coil. Yavaga? When the field strength is doubled in 0.1 second. So this is the field. Field strength B1 is doubled in a time of 0.1 second. ಈಗ ನೋಡಿ ಇದುವರೆಗೆ ಅವನು ಏನ್ ಮಾಡ್ತಾ ಇದ್ದ, ಈ ಕಾಯಿಲ್ ಅನ್ನ ರೊಟೇಷನ್ ಮಾಡ್ತಾ ಇದ್ದ. ಒಟ್ಟು ಮೀನಿಂಗ್ ಏನು ಅಂತಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಆದಾಗ ಮಾತ್ರ ಇ ಎಂ ಎಫ್ ಬರುತ್ತೆ. ಯಾಕಂದ್ರೆ ನಿಮ್ಗೆ ಇಲ್ಲಿ ಕೇಳಿರೋದೇನು, ಫೈಂಡ್ ದ ಇ ಎಂ ಎಫ್ ಇಂಡ್ಯೂಸ್ಡ್, and you know that according to Faraday's law, an EMF is induced. According to Faraday's law, and always an EMF is induced. Yavaga antandre whenever there is a change of magnetic flux, and that's why variety is equal to minus half d5 by dt. Flux change ಆಗಬೇಕಾದ್ರೆ ಮೀನ್ಸ್ ಏನು, ಈ ಫೀಲ್ಡ್ ಏನಾದ್ರು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿದ್ದಾಗ ಕಾಯಿಲ್ ಅನ್ನ ರೊಟೇಷನ್ ಮಾಡೋದು, ಇಲ್ಲ ಅಂತಂದ್ರೆ ಕಾಯಿಲ್ ಅನ್ನು ಹಾಗೆ ಇಟ್ಕೊಳ್ಳೋದು. ಸೊ ನೀವು ಈ ಫೀಲ್ಡ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡೋದು, ಚೇಂಜ್ ಮಾಡ್ತಾ ಹೋಗೋದು, ಫ್ಲಕ್ಸ್ ಡೆನ್ಸಿಟಿ ಚೇಂಜ್ ಮಾಡ್ತಾ ಹೋಗೋದು. ಇವಾಗ ಅವ್ನು ಕೇಳಿರೋದು ಹಾಗೆ. ಇವಾಗ ನೋಡಿ, he has given the number of turns, he has given the radius, so that you can calculate the area. Field strength, your B1 is equal to 2 times the B. ಎಲ್ಲ ಹಾಗೆ ಇಟ್ಕೊಂಡಿದ್ದಾನೆ. ಅವಾಗ ಏನ್ ಮಾಡಬೇಕು, ಸೊ ಇವರ್ change of flux d5 is equal to phi 2 minus phi 1. Phi 2 ಅಂದ್ರೆ ಏನು, it is equal to NA B1 cos theta is equal to, ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು, when it is placed perpendicular magnetic field we are measuring it from the normal, theta is equal to 0. So therefore it is equal to NAB cos theta minus, so this is the final flux and it is NAB cos theta. And remember, your theta is equal to 0. Don't forget that theta is equal to 0. Okay. Now, so cos 0 is equal to 1 then. So when theta is equal to 0, cos 0 is equal to 1. And therefore it is NAB1 minus NAB. And therefore, your NA common factor B1 minus B. This is 2B1. You know that your 2B is equal, the B1 is equal to 2B1. And therefore it is equal to 2B1 minus B1 is equal to B, because your B1 is equal to 2B1, 2B. So 2B minus B is equal to B. Therefore it's NAB. And substitute this value in the equation number 1. Okay. Now you substitute the value in the equation number 1 and therefore you will get E is equal to minus half. So this is equal to 2B, this is equal to NAB, that's all, NAB by dt. He has given everything here. Only the modification that you should make is area he has not given, and therefore you have to calculate the area. It is equation number 2. He has given the number of turns. You can calculate the area because area is equal to, so illen you calculate madra circular coil, it is equal to pi r square. That would be better, pi r square. If r else you substitute it there only. And number of turns is equal to 220 into area is equal to pi into r square into strength of the magnetic field. He has given it as 5 into 10 to the power of minus 2 whole divided by dt. He has given it as a 0.1 second, that you can make it as 1/10 of a second. 1/10 of a second. So ಇವಾಗ ಏನು ಮಾಡಿ, ಎಲ್ಲದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಕ್ಲೀನ್ ಆಗಿ. And therefore your EMF induced E is equal to, it is 220 into 5 into 10. 220 into 5 into 10. Okay, then pi into r square. Pi is 3, radius is 0.1. 0.1 under 110 whole square. Multiplied by 10 to the power of minus 2. You know that this 0, 10 to the power of minus 2 get cancelled. Okay, then what you are left with is, it is 22 into 5 into 3 into 1 by 100. Okay? Because all those zeros get cancelled. Now you simplify this. 22 into 5 is equal to 110 into 3 divided by 100. Get cancelled. Now therefore it is equal to 33 by 10. And therefore that value would be, can put minus sign if you want, minus half 3.3. It is 110 by 100. So you know that 1 0 would get cancelled and it is equal to 33 by 10 is equal to 3.3 volt. And therefore your EMF induced is equal to 3.3 volt. And you check the calculations sometimes if you want. So you can check the calculation if you would like to check the calculation again. So you can check it out. Okay. So it's very simple problem. It is very simple problem. See, the problem is a rectangular coil of wire having 10 turns. Here inside we are now using rectangular coil. So it will have a length and breadth. Rectangular coil, which will have a length and breadth. And what you have said is they are having 10 turns. So you have 10 turns in that. And the dimension of 0.3 meter and 0.2 meter. That means he has given the area 0.3 meter into 0.2 meter. And you know that comes out to be equal to, so that's equal to 0.3 into 0.2, and you know that it is equal to, so 6 into 10 to the power minus 2 meter square is the area. Rotates with a constant speed of 600 RPM. So he has given the frequency. So frequency is equal to 600 rotations per second. It is 600 rotations per minute he has given. 600, that is, that rotates at the rate of 600 rotations per minute. You convert it, 600 rotations, convert it into the second. 1 minute means it is 60 seconds. So cancel agate, and therefore that is equal to 10 rotations per second. Okay, next. And it is in the uniform field of strength 0.6 Weber per meter square. And then about an axis perpendicular to the magnetic field, calculate the maximum EMF induced. Calculate the maximum EMF induced is equal to V0. So that's why you should remember the formula. So, and I hope you know that when the coil is rotated in a magnetic field, and this is the value of V0. You want to calculate the maximum EMF induced. Now it is a very simple problem, and you know that your omega naught is equal to NAB omega, equation number 1, or you can substitute that. Your omega is equal to 2 pi f, and therefore your NAB omega means it is 2 pi f. That's the angular velocity. And number of turns. The number of turns he has given it as a 10. Area is equal to 6 into 10 to the power minus 2. Strength of the magnetic field he has given it as 0.6 Webers. And 2 into the pi value is 3.142 into frequency is 10. Okay. This you look at this. It is 2 pi f. Okay. 2 into 3.142 into 10. You look whether it is possible to simplify as it is. Okay. So you have got 110 here. 10 to the power minus 2. 110, that gets cancelled. Okay. Now you have this 0.6 into 6 is equal to 3.6, and these 2 is equal to 6.28. Okay. Now you simplify that. So you simplify, that is a 3.6 into 6.28, and that comes out to be 22.6. Okay. This comes out to be 22.6 volt. That's all. This is the maximum EMF induced. Therefore, you write at the end a sentence. Therefore, the maximum EMF induced is V0 is equal to 22.6 ವೋಲ್ಟ್. ನೀವು ಈ ತರ ಬರೆಯೋ ಅಭ್ಯಾಸ ಮಾಡ್ಕೋಬೇಕು. ಅವಾಗ ಏನಾಗುತ್ತೆ ಗೊತ್ತಾ, ಪ್ರಾಬ್ಲಮ್ ಏನ್ ಮಾಡಿದ್ರಿ ಅಂತ ಅರ್ಥ ಆಗುತ್ತೆ. ನಿಮ್ಗೆ ಇಲ್ಲ ಅಂತಂದ್ರೆ ಅದೇನೋ ಡೇಟಾ ಬರೆದ್ರು, ಫಿಗರ್ ಬರೆದ್ರು, ಫಾರ್ಮುಲಾ ಹಾಕಿದ್ರು, ಸೊ ವಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. ಯಾವಾಗ್ಲೂ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಿದಾಗ ನೀವು ಲಾಸ್ಟಿಗೆ ಈ ಸೆಂಟೆನ್ಸ್ ಬರೀ ಅಭ್ಯಾಸ ಇರಬೇಕು. ಇದು ನಿಮ್ಗೆ ಜ್ಞಾಪಕ ಇದೆ ಅಲ್ವಾ, ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಿ ನಾಟ್. ಡಿರೈವೇಶನ್ ಹೇಳಿ, ಮ್ಯಾಕ್ಸಿಮಮ್ EMF ಇಂಡ್ಯೂಸ್ಡ್ ಇಸ್ ಗಿವನ್ ಬೈ ವಿ ನಾಟ್, ದಟ್ಸ್ ಈಕ್ವಲ್ ಟು ಇದಕ್ಕೆ ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು. ಯುವರ್ ವಿ ನಾಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು NAB ಒಮೆಗಾ. ಓಕೆ, ಇಲ್ಲಿ ಅವ್ನು ನಿಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕರೆಂಟ್ ಕೇಳಿಲ್ಲ. ಸಪೋಸ್ ಇಫ್ ಆಸ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕರೆಂಟ್ and you know that your maximum current is given by I naught is equal to V naught by R. Suppose if he gives the resistance, if V naught is known, you can calculate the current. Okay, it's a very simple problem. So the problem number 9, a 10 ohm coil, they have given the resistance of the coil as 10 ohm and has 220 turns. Number of turns is equal to 220. And then is placed perpendicular to the magnetic field between the two pole pieces of an electromagnet. A current of 1 milliampere flows. A current of 1 milliampere. 1 milliampere means 10 to the power minus 3 ampere flows for a time of 0.1 second. It says current flows for a time of 0.1 second through the coil. Through it, when the coil is removed from the field, calculate the magnetic flux density. What's the magnetic is nothing but magnetic flux density means you have to calculate the B. Remember that. So you have to calculate the magnetic flux density between the pole pieces of a magnet. Look, all these things are related to the what is known as the EMF induced. Okay. Now he says he has a coil and the resistance is 10 ohm, number of turns ಕೊಟ್ಟಿದ್ದಾನೆ, ಕರೆಂಟ್ ಇಷ್ಟು ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ. ಏನ್ ಮಾಡ್ತಾನೆ, ಆ ಕಾಯಿಲ್ ಅನ್ನ ಸಡನ್ ಆಗಿ ಹಿಂಗ್ ರಿಮೂವ್ ಮಾಡ್ತಾನೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಫ್ಲಕ್ಸ್ ಡೆನ್ಸಿಟಿ ಚೇಂಜ್. ವಾಟ್ ಇಸ್ ದ ಫ್ಲಕ್ಸ್ ಡೆನ್ಸಿಟಿ? ಕಾಯಿಲ್ ಸಡನ್ ಆಗಿ ತೆಗಿತಾನೆ. ವಾಟ್ ಇಸ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದ ಫ್ಲಕ್ಸ್ ಡೆನ್ಸಿಟಿ? ದಟ್ಸ್ ದ ಫ್ಲಕ್ಸ್ ಡೆನ್ಸಿಟಿ ಮೀನ್ಸ್ ಜ್ಞಾಪಕ ಇರಬೇಕು. ಇಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದ B he is asking. Okay. Hence, I will formula ಮಾಡೋದು. You know that according to Faraday's law, you know that your EMF induced is given by the formula minus of d phi by dt. Okay, and you know that your E is equal to V, which is nothing but the IR. Okay, and therefore your IR is equal to minus half. D phi ಅಂದ್ರೆ ಏನು? The change of magnetic flux. ಇವಾಗ ಅವ್ರು ಏನ್ ಮಾಡಿರ್ತಾನೆ, when he takes out the coil suddenly, ಮೊದಲಿಗೆ ಫ್ಲಕ್ಸ್ ಇತ್ತು, now the flux changes. ಜ್ಞಾಪಕ ಇರಲಿ. And this change of flux is d phi by dt, equation number 1. The flux d phi is given by the formula phi 2 minus phi 1. What is your phi 2 is equal to NAB. So it is NAB cos theta minus this is also NAB cos theta. But here your B is equal to 0. Angle is not changed. ಈಗ ಏನ್ ಮಾಡ್ತಾನೆ, ಸಡನ್ ಆಗಿ ಹಿಂಗೆ ಎಳೆದಾಗ what's the magnetic field is equal to 0. Other flux is equal to 0. Whole flux is equal to 0 minus NAB cos theta. But you know that your theta is equal to 0. Okay. Suddenly he pulls out of the field. Therefore it is equal to your d phi is given by the formula minus of NAB cos of 0. Cos of 0 ಅಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ 1. Therefore your d phi is equal to minus of NAB. ಸೊ ಇದು ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಬೇಕು. ಮೊದಲು ಹಿಂಗಿತ್ತಲ್ವಾ, ಇನಿಷಿಯಲಿ ಇಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು NAB cos theta. ಇವಾಗ ಏನ್ ಮಾಡ್ತಾನೆ, ಈ ಸಡನ್ಲಿ ರಿಮೂವ್ ಮಾಡಿದಾಗ ಅವಾಗ ಏನಾಗೋಯ್ತು, ಚೇಂಜ್ ಆಗೋಯ್ತು. ಮೊದಲೇ ರೀತಿ ಫೈನಲಿ ಚೇಂಜಸ್ ಟು 0. ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ ಆಫ್ NAB and therefore you substitute in the equation number 1. Therefore your IR is equal to minus of it is NEB divided by dt. And therefore, your IR is equal to, so minus NAB is equal to plus NAB by dt. So what you want to calculate is equal to B and your IR into dt divided by N into A. Substitute all those things. So number of turns is equal to 220. Resistance of the coil is equal to 10 ohms. And in a time of 10 seconds, and it is 0.1 second means it is 1 by 10. So you try to write those things, 1/10 of a second. Divided by, here I is 1 milliamps. I is equal to 1 milliamps into the resistance. 1 milliamp is equal to, it is 10 to the power of minus 3. And number of turns is equal to 220. And has he given the area of the coil is not given here. And he has given the area of the coil is equal to, focus 20 into 10 to the power minus 4 meter square. Area is given to be 20 into 10 to the power minus 4. So ಏನು ಮಾಡಿ ಇವಾಗೆಲ್ಲ rearrange ಮಾಡಿ terms ಎಲ್ಲ. So ಈ 0 cancel ಆಯಿತು. And therefore your 10 to the power minus 3, 10 to the power minus 4 would come as a plus 4. And here is you have 220 into 2 is equal to 440 into 1 more 10 here you have. Okay. Now 2 zeros would get cancelled here. Now you can work it out, and therefore it is equal to, so 10 to the power of 4 and 2 zeros, it is 10 to the power of minus 1, and it is divided by 440. Okay. Now I think you can work it out. That value comes out to be equal to, so 1 by 4400, 1 divided by 4400, that comes out to be, okay. So we calculate it again and we'll see whether it would fetch a, we can do it still in a better manner. And your I is equal to 10 to the power minus 3 and your R is equal to 10 and dt is equal to 10 to the power minus 1, you can write the time 10 to the power minus 1, and number of turns is equal to 220 multiplied by area is equal to 20 into 10 to the power minus 4. And therefore this value would be 10 to the power minus 1 and this 10 get cancelled. And here is 10 to the power minus 3 and 10 to the power minus 4. You will have 1 minus 1 0 and it is equal to 1 by 4400. Therefore you can work it out to be 1 divided by 44 and that comes out to be 0.02. You can write as so much or it is equal to Weber per meter square. So much of Tesla or it is Weber per meter square. Okay. So your calculation is here now it is equal to 2 into 10 to the power of minus 4. Okay. So very simple one. Okay. Remember this. This is a problem on the electromagnetic induction. Okay.